Assalamualaikum. We are from Group E, gonna present our assignment 1. Our title for assignment 1 is Wine Case Study using MATLAB. There are 3 members in our group, Hijrah, Nordina Izzati, and Zahida. Next, for introduction, artificial neural networks ANNs are advanced computational models inspired by the human brain's ability to process complex patterns and make decisions. In data science and machine learning, ANNs excel in tasks such as classification and pattern recognition. The goal for our assignment is to develop an artificial neural network model to accurately classify wines based on their chemical attributes. Next is to aiming to classify wines from the wine dataset into 3 distinct cultivar classes. Next, for data description, the dataset is from MATLAB, which is wine dataset. Dataset contains 13 continuous attributes representing chemical properties of the wine. Dataset divided for training, validation, and testing purpose. 70% for training, 15% for testing, and 15% of training data for validation. Next, for learning process. For data preparation, standardize wine chemical properties and include wine types. Initial layer setup of 13 layers to be optimized. Next is loss function. Cross entropy used to measure model accuracy. Low error signifies better alignment with actual data. For optimization, stochastic gradient descent (SGD) adjusts weights and biases to minimize cross entropy, controlled by learning rate to prevent overshooting. For validation, split data into training and validation sets to gauge generalization. Fine-tune based on validation performance. Lastly is evaluation matrix. Confusion matrix assesses classification accuracy. Visualization aids in interpreting and validating model predictions.
Next, this is the flowchart of the case study. First, we need to open NPR tool in MATLAB and then import the wine dataset. And then we will set the training, validation, and testing data and set the number of hidden neurons. After that, we will train the data and then check the result of the trained data. If the result of the trained data is not good, we will set another training, validation, and testing data, and then we will stop until the result of the trained data is good.
Step-by-step learning and analysis. Step 1. Starting the NPR tool. After starting the NPR tool, we will be displayed with the NPR tool GUI. Next is importing the dataset. Click the import button, hover over more example dataset, and then click on import wine dataset. Step 3. Setting the parameters. We set the parameters by manipulating the validation data, test data, and layer size. We use the split of 80, 10, and 10 to teach our model. Layer size is set to 12 to accommodate for each attribute. 12 layer sizes mean there are 12 nodes inside the neural network. Step 4. Acquiring the training result. The results are acquired by referring to the table inside the NPR tool. It gives the epoch, performance, gradient, and validation checks. The results can further be analyzed.
This is the analysis and results of the trained data. This is the result of the first run, which we already set the training data at 80%, testing data at 10%, and validation at 10%. From the cross-entropy performance graph, we can see that the best cross-entropy for the validation set is placed at 0.0001145, which is a low value. A lower value signifies fewer errors in the prediction. For the training set, we can see that the curve is steadily decreasing. It means that the model is learning from the data. For the test curve, we can see that it shows a steep decline and then stays roughly the same until the final iteration, which means that the model is performing well. For the confusion matrix of first run, we can see that the model has successfully predicted the classes correctly because the true positives are in large amount compared to the false negatives and false positives. For the second run, we have set the training set at 65%, validation set at 10%, and the testing set at 25%. For the cross-entropy performance graph for second run, the model is still performing well, but compared to the first run, the accuracy from the first run is better than the second run. This is because the training data in second run is lower than the first run. The wine dataset is a small dataset, so a large split of the training data is needed for the model to learn patterns more effectively.
In conclusion, through the MATLAB Neural Network Pattern Recognition Toolbox, the project was aimed to classify wines based on their chemical properties. The goal was to achieve high accuracy in predicting the correct wine cultivar classes, aiding decision-making in the winemaking industry. By iteratively adjusting the model parameters, the ANN minimized the errors and optimized the performance. Evaluation showed high predictive accuracy and low cross-entropy, indicating strong model performance and reliability. That is all from us. Thank you.